Well, thank you very much. So I'm going to talk a little bit about cybersecurity here, and I always just like to share this image as sort of one of my heuristics in terms of what we're getting into here, which is, balancing our ability to do science versus the risks involved. And Eva mentioned Trusted CI, which is a center I've got the privilege of leading, which serves as the NSF Cybersecurity Center of Excellence. And I won't read you the mission statement that's up there, but the key to understand is this is a center that is primarily focused on providing practical guidance and assistance to NSF projects in tackling cybersecurity and related challenges. And I often get asked, most NSF science tends to be very open. It's not like NIH science where you're dealing with personal health information. So what are cybersecurity challenges? And just briefly, I like to think about them in these three categories. We talk about productivity, the availability of our scientific instruments and high performance computing, etc. We talk about trustworthiness, knowing that the data that's resulting from our scientific processes can be relied on to be accurate. And then really focusing on what we're talking about here today is the role of cybersecurity in enabling reproducibility. And about a year ago, the four of us wrote a paper for the PREX workshop with some initial thoughts on that overlap of cybersecurity and reproducibility. I would encourage folks to go take a look at that paper, particularly if you're interested in research topics around reproducibility and cybersecurity. I think there's a number of them, and I know I'm not personally going to be able to tackle all the thoughts we had up there, but I'm hoping that it serves to encourage some thinking and some research in that area in the community. I've got up here on the screen right now one area that we explored in that paper, which is the impact of data integrity on reproducibility. And now what I'm going to do is jump into some specific work on data integrity that my colleague Eva Dielman and I have done in a related project called SWIP, which is the scientific workflow integrity protection, where we added integrity protections to her very popular Pegasus workflow management system. And I'm not going to go too much into the engineering around that, but talk more about some of our motivations and then some of the results we saw once we added that integrity protection. What sorts of things did it catch? So first, the word integrity can be a little bit fuzzy. We often use it in a very high way, talking about scientific integrity. Today, I'm using it very specifically in the area of data integrity and bit flips. And so some of our motivations into why we're looking into this, the first I'm going to point out is a study done at CERN on integrity of disks and seeing errors. Essentially, once you get to large enough scale, these statistical issues start creeping in. We have other examples of errors in our IT networks with data integrity errors sneaking in. I'll summarize these briefly. It's that a well-meaning network software developer for one of these high-performance network switches introduces something to increase performance, makes an error, and they end up miscopying data as it passes through a switch or a router. We've also seen bugs in the software stack where they go to write data out, an error occurs, doesn't get caught, and this ends up then propagating and ruining whole workflows downstream from that particular issue. So a case here of sort of a gross data error. An interesting one I throw in here, if anyone else is a fan of the podcast Radio Lab, they did a fascinating show on issues around a election in Brussels back in 2003. And there was a case where more votes were cast for a candidate than there were people in a particular town. They started digging into it, and they found out the difference between 2 counts of votes was exactly 4,096. The general public may find that number baffling, but I'm sure people in this room sort of get the significance of that number and how it led to that. So this led to the goals of the SWIP project in providing assurances for scientific workflows around data integrity. So just very quickly, we ended up producing a version of Pegasus that had integrity protections in it through the workflow. So you may have certain tools today like Secure Copy or the Globus, offers you integrity protection when you're doing a file transfer. The advantage of doing it into a workflow management tool is the workflow management tool can end-to-end know every step that is going through and actually do checks all along the way. And so we produced the version 4.9 of Pegasus has this on by default. And then we also have some reporting that comes back to us. And in the case of some of our earlier users, they were kind enough to give us some transparency so that when we got errors reported back to us, we were able to pierce the privacy we provide to normal Pegasus users and actually do some debugging. So one workflow we saw was a job that was running on the Open Science Grid called OSG Kink, and we saw a case there where suddenly it encountered a whole burst of integrity errors, about 60 some odd. Now these jobs were all automatically retried. They took place on different hosts, and they were somewhat spread out. A couple looked to be sort of case in point, but 56 were bundled up. Now, one thing we learned is it can be very hard to diagnose these integrity errors after the fact, but we're highly suspicious here that a cache got corrupted, and so then a local fan out on that particular site then resulted in all those jobs being corrupted. Another case, working with a Nepomuk OTE down at Georgia Tech in the Veritas workflow, once again seeing a small stream, 0.04%, very small, of these errors doing transfers. In this case here, we believe the diagnosis was using a transfer mechanism that didn't have built-in integrity protection in their workflow, and so we suspect this is a case of those very small number of errors that can slip through a TCP checksum coming through. So we're seeing evidence that this is real out there. So just some takeaways, boiling this back up into my role of trying to provide scientists. The high level thing is, first, don't believe that our IT infrastructure is perfect. Particularly as we get to days of large data and larger data sets, you start taking the data sets and bit error rates and multiplying them, and the results are that we're going to start seeing more and more of these. Now, one thing we admit is the impact is going to be very science specific. Right now, I have nothing leads me to believe if you're involved in something that's doing analog to digital conversion off of something, you probably have so much noise in that particular error that the data integrity is not a concern. However, I am concerned when I start talking to projects that maybe are passing around social science data or other things where a bit flip can be very significant in terms that it's changing your belief about attributes of subjects or people or whatnot. The other thing I advise scientists to consider is because of the increasing politicalization of science, we're seeing more claims of data being altered, particularly, I'll just put you into the mind here of climate science right now as a case where this is really happening. Could you defend your scientific workflow against accusations that may be baseless, but still nonetheless, could you defend your workflow against accusations of data errors or manipulation? Do you have a good log of the provenance of whatnot? So specifically, we talk to scientists, talk about them evaluating their risks based upon these factors or others, and then if they do believe themselves to be warranted, to really think about data end-to-end through their entire workflow yes, file transfer tools can solve part of it. Pegasus now has capabilities to do it on the workflow system, but there are always parts of the workflow at the edges that are very human-centric, and to include those too. Eva mentioned the Trustworthy Data Working Group, and I'll second her recommendation on that. And with that, I'll thank you for your time. I put some references in here to the various papers, and I'll thank the National Science Foundation for the support of the various projects that I've mentioned here today. And with that, I'm going to turn it back over to Michaela.